you feel free to stop me, guys, if you have some questions or any other topics that you may want to discuss. But the idea is to talk a little bit about some learnings I experienced while implementing the subgraph that we have for our own court. The other day, I had my second experience with the graph. I've been playing a little bit with a new subgraph for the agreement sub that I'm currently working on, and yeah, it's just wanted to share some of these learnings. So yeah, know that my experience is not based on any no robust basis. So it's more like yeah, what I did so far from a development perspective, and yeah, maybe there are a few things that were interesting that I discovered myself that I haven't documented anywhere, and probably could be useful to share that knowledge. So yeah, well, the first thing that I didn't like when I started reading about uh, the graph documentation was that they encourage to basically include the ABI of your smart contracts to basically start working with them in your subgraph repo. And honestly, I don't like this idea. That was like my initial interaction with the graph was disagreeing with it. And yeah, basically, what I always like to do is to make sure that, like, if your APIs is part of your project, you should, as a developer, you should be exporting them somehow. As we're doing, for example, with our own apps, we expose the APIs on the packages that we publish on npm or the build artifacts for the smart contracts. And you should simply be able to do something like this, like have a dependency pointing to the subversion that you want to use or the APIs that you want to rely on for your subgraph, instead of simply copy pasting here the API. So if you look for some APIs here, you won't find any. I mean, this is the Herd subgraph repo, for example. Always, of course, having not having duplicated logic is good, especially to make sure that you're yeah, you can miscopy the APIs, and that would be really bad. Like thinking that you're working with a certain smart contract version that you're not, that would be really bad. And here's an example of what you shouldn't do. This is what the documentation of the graph says, but this is, for example, what I did yesterday for the agreement sub. Basically, the agreement sub isn't published yet, and since we're working with a learner repo, it's kind of weird and difficult to link to a GitHub branch or something like that to install the dependency. But ideally, you shouldn't be copy pasting the APIs in your subgraph repo. Just make sure you have the dependency of these smart contracts that you want to interact with. That was kind of the first, yeah, one of my first thoughts when I was reading about the graph. Second of all, creating versus updating entities. So if you're, let's start going into the subgraph logic. As a quick summary, the graph works in a very simple way. It has what they call a manifest, that it's basically a specification where you simply say somehow that you want to track certain events from your smart contract API, and you provide a function of what are you going to do when you receive one of those events. That's, I think we can simplify to that, at least for the purpose of this workshop. And there are a few other things here to configure. I will share some thoughts about this later, but for now, let's simplify the scope of the subgraph to this. So each of these functions are basically described and exported somewhere, and you will see that, for example, one of the ways to create entities in your Subgraph, basically, apart from defining all these mapping from events to handler functions, you basically define a schema, GraphQL schema, and that's basically the entities that you want to store in your Subgraph. You can think this as a database model or something like that. So basically, your handler functions are going to be parsing information from the events and creating instances. That's basically what you're going to try to do, at least for a basic example. So yeah, going back to the topic, creating versus updating entities. Basically, there are two ways to create or update. One way for creating and one way for updating instances. This is the agreements subgraph. Let's see one of these examples. So, for example, in order to create, let's find an example of where am I creating an instance? I should have one here. Yeah. So every time you call new, you're creating an instance, and you don't know from an event perspective. I mean, you receive an event and you don't know if that entity was created or not, and you need to create it beforehand if you're willing to update it. So this is something that the Subgraph JavaScript, TypeScript classes that they provide to interact with your events or your entities, they don't provide it like built-in, so you will need to manage that by yourself. It was quite frustrating that I was thinking like this doesn't work as a find or create or something like that. So if you're loading something that wasn't created before, you won't be doing anything. And if you simply do new every time without loading, you will be overwriting your previous information. So yeah, if you're like debugging this, took me a little while until I understand or figure out the common pattern I use everywhere to have this nice find or create or functionality that basically tries to load an entity, and you basically check if there's any, and if there isn't, you just create a new one and you return that entity. So basically, I use this pattern everywhere. In the core Subgraph, you will find it so many places. As you will see, well, for the rounds, for example, of a dispute, you basically doing this for your dispute yourself as well. For appeals, everywhere. Like there may be sometimes that you cannot know from an event if a certain entity was created or not, and you will need to handle that manually. So make sure when you're thinking that you're creating an instance, if that instance should have existed before or could have existed before, and if you shouldn't consider adding some workaround to this, because you will be overwriting or missing information, and it's hard again to debug that and to notice that no one is going. I mean, the graph is not going to warn you, hey, you're overwriting data or you're missing some past data. So this is a good thing to bear in mind while parsing events. Okay.
A quick question here, Faku.
Sure.
So when you mean that it gets overridden, that's really only a problem if you wanted to load the event and change something based on that? Or say,
exactly.
Okay, like you want to load an entry and then use that entry to like change the number of votes or something like that. But if you didn't have it before, then you would just always be inserting one.
Exactly.
Okay.
And one question also on that is: Is it the case that all the object is updated, or only the sections that are new?
Yeah, that's the problem. Although, actually, you can think it like, let's say I receive. This is probably useful when parsing I think I had this problem when I noticed it the first time with balances. So because in the code we store like you know that NJ balances have like different states that they could be going through, and there are many of them. So for example, let's say that you handle an event that tells you that certain balance will move from state 1 to state 2, but you have state 3, 4, and 5 for balances for a juror. So if you're handling that event and thinking that you're creating a new instance of an entity, saving the state transition that you receive, you will be overwriting all the other states that you could have for the same guy. It basically meant like setting to 0 all the other balances. Instead, if you call load, you wouldn't be overwriting the rest of the balances, because that's actually what you need to do. You need to update like a certain state balance for that guy, not all of them, because you're handling one specific transition event. So yeah, that's what I meant with overwriting. You can assume it as like dropping a previous instance and creating a new one. If you call new, otherwise if you call load and you update only a few fields from your entity, you will be just updating those. You don't need to override the rest of them.
And so on this piece of code that we're looking at right now, the reason we're not calling .save at this point on the round and we return it is because we expect to do that from the call save.
Basically because, you need to call save. I mean, every time you're working with an entity, I see this a bit redundant. It's good that you can manage when to perform this transaction to the database, let's say somehow. But yeah, I mean, if you're updating some data, you will need to call save at some point. I just don't call it here because another common pattern that I saw is that loading or creating the instance means like initial step that I will then use to update the rest of the data that I need that I want to store for that instance. So that's why I don't call save here, because I probably know I'm updating the rest of the entity fields after calling load to create every time, as you can see here, for example. So a common pattern is like load to create, then I update the rest of the things that I want to update and make call save. And you will see this for, as you can see here, for the appeal. I'm loading or creating the appeal, then I update the appeal, and then I save the appeal. I'm sure we can find another example while around. We already saw this. For example, the balances here they are. I load the balance, but then I update it. Just probably only one field for the sender. And then I save it. I will upgrade the balance for the recipient. I update only the amount attribute of it, and then I save it.
Okay.
But I don't save it here. Another important thing to notice is that there are no default values here. So you will need to provide, if you specify that some values are non-nullable, you will need to specify default values manually. So for example, especially coming from smart contracts, you would assume that if you specify a big int for an attribute, that it will start at 0, and it doesn't, you will fail, and TypeScript doesn't detect it at compiling time. So when you deploy the subgraph and you try to create a new instance, if you didn't specify this, you try to save it, you will basically break. So that's an important thing to notice. Any other question around loading, creating entities?
I have one, but it's a bit related. I think it's when you configure the Subgraph template, the data sources could be from different contracts and will be loading events to the same entity. Because I was not 100% sure on that.
Let's see if I follow correctly. You mean
if you configure several data sources, but from different addresses, and you try, but you handle the same events, do you are able to?
That's interesting.
Use the same entity. I believe it's the case. If I understood correctly in the documentation, but want to double check.
Yeah, I honestly I didn't try that, but I would assume there shouldn't be any problem, like tracking different addresses for the same events. You mean?
Yeah, because I think for the DAO factories to be the case.
Yeah, that shouldn't be a problem. Not sure how you can specify like multiple addresses here. Otherwise, of course, I think you can repeat the entire data source, but
yeah, I think you need to do that.
But yeah, I think that there shouldn't be a problem. It will be like I was saying that maybe you can use templates somehow, but you will need to know programmatically which are the addresses of those factories that you want to track. Events, I mean. I think you won't be able to do that.
Yeah. Thanks.
Okay. Okay. This is another interesting one. Building unique IDs. So this happened to me when I was trying to track ERC20 transfers. So let's see an example here. You can think that, I don't know, easily if you want to track like ERC20 balances, that will be easy because you can define IDs for the balances entities using the address of the token holder, and just specify like an amount for each address, and that's it. You can track ERC20 balances easily. But what would happen if you would like to track the transfers that an address did? And that will basically mean creating one entity for each, like one entity instance for each transfer. But you need to provide like an ID, because all the entities in this graph must have an ID field, and you will receive a warning if you don't do that. So basically, you will see that all the entities specifications start with this ID field. You don't necessarily have an ID for a transfer. You cannot use a transaction hash. You can use like a timestamp or something like that, because in a transaction could be more than one transfer, and you won't be creating multiple entities for each transfer if you do that. So what based on some conversation I had with the Graph team before, it seems like there is no native support for like generating IDs for this. So I came up with this useful thing that it's quite simple, but it's interesting to know that it works and you can rely on this. Again, double check with the Graph team. So basically what I'm doing in order to build an ID from an event, it's using the transaction hash plus the login, the log index. This would be like if you have multiple transfers inside of the single transaction, each of these will have a index, and the transaction hash, of course, is unique in the world of transactions, in the universe of transactions. So you can rely on this. And this is quite useful. There were many things. I started with the ERC20 transfers, but there are many things that don't have an ID because of its own nature, and yeah, you will need to manage. You have some way of identifying those entities uniquely and doing that manually. So probably again, you can rely on transaction hashes and log indexes. We can see an example. But I'm sure it was for the transfers, definitely. Yeah, well, I'm not using the help here, but you will see the same logic. So every time I handle a transfer event of an ERC20, I was creating an ID based on this. And well, this, I think I forgot to update this part of the code, but this is kind of similar to the load or create logic that we saw before. So it's basically checking if there's a transaction missing, and it's not, it creates it and it updates it. So yeah, any questions, or I don't know if you experience the same issue and you solve it in any different way. Maybe you can share that.
So I guess this is primarily useful for not using the ID to do a filter, because getting this ID from a front end would be quite difficult to do.
In order to filter, you mean?
Yeah. So for example, if I wanted to find just a specific transfer event, well, I guess if I know the event and if I have the event data, I can probably go find both the log index and the hash to just search for this.
Yeah. If you know the event data, you basically can build this ID and create it. But yeah, I think the interesting part here was to be able to know I can show you what we're actually doing with this. Just an example of our own code. Well, this is only to find one that has a few transactions. Well, here you can see basically this guy converted 3 times an amount of ANJ and transferred once to this address. So basically, you can have like a set of transfers that someone did, for instance, specifically ERC20. But yeah, if you want to query like one particular transaction, you will need to know that particular ID. Okay, where was the agenda here? Querying information from smart contracts. So this is actually good, and yeah, something that I started thinking was I actually started thinking this before, like working with the graph. Sometimes I think like, do I really need to log this information when I am emitting an event from the smart contract? I mean, is it really necessary? Sometimes I think that events should help, should hold the least information that you can emit, but only if you can make sure that the rest of the information for whatever thing you're trying to store an event could be fetched after that based on the information that you're logging in the event. Not sure if that was so clear, but let's see a quick example. So, for example, again, let's see the agreements app that I was working recently. So, for example, you can see that I don't know, every time I create an action, let's not worry about what an action is, but let's say it's something that has an ID and a few attributes related to it. I can build a UI just emitting a single event, a single argument here with the event that is the action ID, and I could provide like a view getter then to get the rest of all the information related about an action without having to store necessarily, for example, one particular attribute, the submitter of the action, in the event itself, because I will be duplicating data. I'm emitting that information in the event, but I'm storing that in the contract storage as well. So I'm duplicating that data. It means like paying more gas for that. Maybe it doesn't make sense. I haven't come up with a conclusion yet, but I'm kind of inclined to the idea of only logging the minimum amount of data that you can log in order to be able to fetch the rest of it afterwards. And that's how that's one of the really cool things about the graph, that you can, every time you're handling an action, event, you can basically build a wrapper similar to what we usually do with Truffle or Web3 of your smart contract, and call the getters or the view functions or pure functions of your smart contract. So yeah, let's see an example. So, well, we can probably use the same example that I was showing in the smart contract. So, for example, this is the action schedule event that I showed here in the smart contract. So, as you can see, it logs the action ID and the submitter, but it has many other attributes that aren't being logged here. And how do you store that information in your Subgraph? Well, it's easy. It's super easy. Basically, the graph tools, in the same way they provide like TypeScript wrappers for your entities, they provide like TypeScript wrappers for your smart contracts that you can simply call this, you can import them. This is the agreement tab wrapper for the smart contract, and you call instead of this would be the smear to what we use with when we're working with Truffle contracts or Web3 or Ethers. I think they have the same nomenclature. Here it's called bind. You simply pass an address and you have your smart contract here, and you can start calling a getter or any view function here. And it's exactly the same as working with Web3 wrappers or something that is, you will find it super familiar. Here's the getter. You simply specify, in this case, an action ID, and you will receive all this data. And it's exactly what we're doing here. We store the data in a variable, and then we start like moving pieces from the variable to the entity that we created. And that's it. It's quite simple to call any view or pure functions from your smart contract, and that's pretty useful. And it will help you setting gas and contract size when you're working or with events in your smart contracts. Any thoughts on this? I would love to see if I'm the only one thinking that logging the minimum is a great idea, or if you see like a huge con on doing that. Of course, like all the it will be hard to to find data in the logs itself from like if from places like Etherscan or something like that. But again, if you're providing a way to query the rest of the information, I think this is somehow redundant.
Yeah, I would definitely agree with that. I think the dream of being able to log everything is is very much still a dream with where we are today. I mean, there's a couple of use cases where I think you'll need to log more information, like a bytes metadata. If you don't want to store that expensively in storage, you can just log it, and that's quite nice. Other times it's just really indexed parameters, and like there's an argument to how good the index is by itself, but like maybe they will help you in the future to do some quick filtering in the events themselves.
Yeah. In that case, I agree. Of course, in the case of bytes data, if you're not storing that in the smart contract, that would be useful and it wouldn't be redundant. So yeah, definitely. But yeah, so I think like being that easier with tools like the graph. I think we can start like saving some gas from our users. And saving some storage in the Ethereum blockchain without storing data in two places: the storage and the logs. Yeah,
definitely. Just to go back to the code quickly. A quick question here. In terms of building the action ID, it looks like we're. Oh no! So this is using the agreement address plus the action ID.
Yeah, okay. This is this was a particular case of, but interesting though about agreements. So this Subgraph basically is tracking information from any agreements or any organization that has been deployed from a specific factory right. So why I'm doing this, it's like simply because I cannot rely. We cannot assume that, of course, an action ID from an agreement instance will be unique in the world of agreements. So what I'm doing here is kind of similar to what we did with the ERC20 transfers. I'm mixing the agreement address with the action ID for that agreement instance to build a unique ID. Because otherwise, like identifying my actions in the subgraph only with the action ID won't be enough.
Yep. Yeah, it makes sense.
Great. We talked about this. Debugging. Okay, great. So it's really hard to debug. At least I'm not so. I don't find it super friendly to find to debug a subgraph. Let me show you one quick thing that it's in the documentation, but it's I think they show like just one line about this, about how you can log things like similar to console log in the subgraph. Let me try to find it. So they have this super small section here about logging and how you can use it to debug your subgraphs. It's like there are no breakpoints or something like that you can use, but you can log some arbitrary information. So for example, again, going to the agreements subgraph. Let me show you an example of what this is logging. So what I did here was to, for example, I added a few logging instructions here. Every time a new DAO is deployed, I was just logging the DAO address. This log event object is imported from the graph library. It's not like the console log or something like that. It works similar to Java. So yeah, not sure if you found it familiar. But then you can go into the graph explorer and see the logs and filter. This is quite useful. Okay. Oh no, debug. Sorry. So you will see here. These are my no. This one no. Yeah. Yeah, I think these are my logs. This one in particular. So it's quite useful to make sure that you're handling the right events or parsing the information in the proper way that you're expecting to parse it. That one in particular was from here. For example, new proxy from app ID. But I didn't find any other way to debug it, honestly, besides logging. It works as well, yeah, for if you're running a graph node locally. But yeah, it's again not sure if you experienced any other way to debug Subgraph, but it's quite painful. And but yeah, this was the only way I found to do it. Automated testing. There's nothing much to say about this. The only thing I experienced is that I tried for a while to write automated tests for these kind of functions to make sure they were working properly. And it was a pain in the ass trying to set it up. So I dropped it. So unfortunately, there isn't much to share about automated testing with subgraphs. But my point here is that automated tests are always useful, and they will always save you time when trying to debug this. So let's try to for the future. Let's try to find a way to do that. The good thing is that given that we're using TypeScript here, many of the things, if you have like typing errors or something like that, type errors, you can catch that before deploying and trying out your subgraphs. But again, it's not covered 100%. So again, if someone did try to find a way to do some automated testing, please share your thoughts. Okay, we're good with the timing. Tracking contra events for instances that haven't been deployed yet. Okay, this is related to what Gabby and I were talking before. So let's see an easy example of how we can do this. So for example, let's say, I was saying before that this agreement subgraph basically tracks events for all agreements instances that are installed in any DAO that was deployed for a certain DAO factory. So what this means, it basically means that there needs to be like an origin point for the subgraph to start parsing events from some point. That point, in our case, is the DAO factory. So we need to specify at least one address to start the events of future smart contracts that will be deployed from that initial contract. In our case, since this is a DAO factory, this DAO factory will start deploying new DAOs, and you can start scrapping the events for those DAOs. And in this case, what we're doing is basically every time a new DAO is created, I'm going to go deep into this in a second, but we are basically creating what is called a template for that particular DAO, and this means basically telling to the graph, hey, please start tracking the events for this DAO with this template. And a template means, again, a set of instructions. With these instructions, I mean a mapping from events to handler functions that the graph will start evaluating for all the events that were specified for this new address that I didn't know beforehand. because of course I don't know all the addresses of the DAOs that will be created from this factory. The way to specify this is in the manifest again. So basically, the manifest has two main entries. One is data sources, and the other one is templates. Both share the same structure with a difference of just one field, and that field is basically the address. In this case, yeah, you're seeing they're like handlebar. I will go into. I will explain this later. But usually you see here some sort of address, and it basically means that again you will try to use this mapping from events to handler functions in order to parse the events of this address, and you can define then templates you will use for future contracts that you don't know the address yet. And it's exactly the same structure. You define a set of AVIs that you want to use to for the events that you're going to track for that smart contract. Again, events and handler functions where those handlers are defined, blah blah blah, some naming, etc. But it's again exactly the same. The only thing that they differ is that you don't specify an address because you don't know that beforehand for the templates, and that's it. You just need to make sure to create them in the right place whenever you want to start tracking the events for those smart contracts. Again, in this case, for example, we're doing it with the deploy DAO. It's quite easy. For the case of the court, it was a bit more difficult. We did it in there's a module set event that basically, in the way the Aaron core is structured, there are many all the different parts that compound the Aaron core protocol are called modules, and there's like a single controller that basically allows to plug or unplug modules from it. So basically, the module set event is triggered every time a new module is set or plugged into the protocol. So what we're doing there is basically create a different template based on what was the module that was plugged. So that's why we're doing here reading the ID of the module, if it was the yours registry, or if it was the voting module, if it was the treasury module, the dispute manager module, whatever. And we're creating different templates based on that. With this, we can make sure that we're going to track every module that will be created for the Aaron core protocol. Again, and we only need to provide one single address, which is the controller of the Aaron core. The rest of the modules are going to be tracked automatically after that. So this is quite useful. It reduces basically the configuration that you will need to deploy Subgraph. I mean, if you manage it properly, in best case, you will need to know only one address to build a Subgraph, not all the smart contract addresses of your protocol of your system. Any questions about this?
In terms of templates, is there a way for us to unlisten to one based on an event?
That's a great question, and I didn't find a way to do that. I actually need to check with them, but yeah, I don't know. Actually, let me check it quite soon. I think I already checked this, but no. As you can see, they provide here like a create function, but there's no like destroy or something like that. So I'm not sure if there was a way to do that, but it would be useful.
Gotcha. And I guess the only way we would be able to achieve this now is by like checking against an ID. Like if we knew we were only looking for a specific set of contracts, then we would always check that on every event.
If you want to stop like listening for a certain module, do you mean?
Yeah, exactly.
Well, what we could do instead of doing that, like since I think every time you deploy a new version of your subgraph, basically builds and scraps the blockchain entirely. Well, not entirely, but from the beginning. And you can specify which block is the beginning for you. But if you really want to specify like a blacklist of modules that you already know the address that you don't want to track events for, maybe you can add some logic here, like I don't know, something like this. And in that case, you won't be creating a template for that specific event. Sorry, that specific module.
Yeah, that makes sense.
Okay, yeah. This was how to manage Subgraph deployments, especially when you're trying to deal with multiple environments. This is something that we usually need to cover with environments. I mean, like if you want to deploy a subgraph for Rinkeby and another one for Robson and another one for Payne, so on. There isn't a solution built in for that. So actually, you will see that. For example, let's see some of the subgraphs that we created for our own core. You will see this, which is not so nice. We have like different subgraphs for each environment, and this is because they don't distinguish between environments. They just have subgraphs there, and you can like specify as part of the configuration which is the network that you want to interact with. But it's not the same subgraph, and it's not nice because the spec may change for each environment, but it could it could be the same. So yeah, there's no like native way to to share like deployment instructions between these different environments. So let's see how I managed to solve this. So basically, I was referring before to the manifest. And as you can see, this is called actually Subgraph template YAML, not Subgraph YAML. This is the real manifest. And the real manifest does need to hold an address, for example, for the DAO factory, and does need to specify a network name. But in the template, what I did was to provide these handlebars, to be able to build a script that then will later then change it for the real values of these variables, and have an easy way to share this for all the networks. And the start block, for example, is another configuration per network. So this one is useful as well. So basically, what I did was to build this manifest shell script that basically hold the values of these variables for each network. Again, start block, for example, all the factory addresses, and it basically tries to just replace the handlebars with the real values. You do some validation initially here, but at the end, simply using set to replace the handlebars by, again, the network name, the factory, or the start block in this case, because I'm not relying on any other. So it's quite easy. We can deploy one for Rinkeby, for example. So as you can see here, it's well. Let's create the manifest. Let's not deploy a new a new version of the subgraph, but it's super easy. You just need to specify with like this ring key, let's say, which is the network that you want to deploy or you're building manifest for, and just call the script, and you get it there. And as you can see, it again replaces the start block, the factory address, and the network with the proper values. And now I'm able to deploy it using this YAML I just created. Not sure if you guys had similar issues with this, but yeah, I didn't find any, again, native way to solve this from using the graph tools. Not sure if they released something new to manage deployments in a better way.
I think they did the same mustache or underline.
Yeah. Yeah. Yeah, it works well, and it really helped us to manage all the different instances that we have for the core subgraph. But again, it's like something a bit hacky. Yeah. Okay. Setting up a local testing node. Let's see. They're using Docker, so it's quite easy to start a local graph node. But there are a few things that at least didn't work for me. So here I basically this is the graph node repo that you basically clone it, and instead of the Docker directory, you have this Docker compose YAML file that you can use to start the graph node. Before that, you need to have a ganache running locally, otherwise it's not going to connect to anywhere. And you need to specify the host address in a particular way, this 0.0.0.0, instead of doing something like localhost or something like that. It expects this network ID, and it basically expects it to be started in this way. The deterministic flag is not mandatory, but the rest of it is. That's a bit frustrating. And then there's another quick hack here that is you need to remove this data directory every time you need to start a new graph node, especially if you did something with your ganache and you drop it and you started a new one. I think it's because it's caching some of its information, so it basically will break if you don't do this. So I'm removing that. And as you can see, my directory is dirty, and that was because I needed to do some quick tweaking in the Docker environment variables, which was setting this threshold to 0. Don't know why I didn't get deep into this. It was just a warning that was actually, well, not a warning, an error thrown by Docker. So I just set it and it started working. After that, you can simply run Docker compose up, and it should start the graph node properly. And we should be able to use it. So, for example, I can try deploying an agreements subgraph, but I will need to deploy an agreements app first or a DAO factor or something like that. So I'm not going to try that. But again, it works very well for at least doing some local testing just need to make sure that you manage to start it correctly. You can find some of these instructions here in the Subgraph directory, repo, and yeah, all the things that I mentioned are explained here. Here is about the Ethereum reorg threshold environment variable. Okay. And automated schema diagrams. This was one of the ways that I found to build this kind of diagrams. It's what would be the best way to say this? Maybe here. Okay, yeah. So I found like a GraphQL tool that works with GraphBiz. I don't know if you used it before, but basically it parses your schema that you build for your Subgraph in a way that then provides this UML or kind of, well, not UML, but database model automatically. The problem is that your database schema needs to be written in a super specific way that fits for the graph. So you will see, if you have some sort of GraphQL parser or something like that, you will see that there are a bunch of errors with this, especially because of some of these directives or types are not declared here, and they're custom for the graph. And so if you try to run some of these tools with this, will break. So what I did was to have a separate script for that will basically insert the rest of the part that you will need in your schema to make it work. The problem is that we cannot have it here because then the graph deployment will break. That's quite annoying. As you can see, if I just declare the rest of the types there and these things, I don't remember the name now. You can basically have it working properly, and you can run some of the tools like the GraphBiz, and it's working very great. The GraphBiz tool is quite simple. You simply need to specify the schema that you want to parse and where do you want to put the output, and that's it. You will be generating these kind of things that are a bit useful when your schema gets a little bit bigger. Okay, I think that there weren't any other topics in the list. Not sure if you guys have any other questions or things that you want to share or discuss.
Thanks for it was great, and the script also I use it and it's working fine, pretty good.
Nice.
About I would like, if possible, if you like to share a bit more about the process of building the schema itself.
Yeah. Do you want to look particularly into the Aaron port or agreements?
The court, I think it would be much more interesting. Like the process of maybe making the data from the contracts or some specific part to the schema.
Okay.
Yeah, I think for the interest of time, we do have to jump to a couple other things, but perhaps this is something we can do offline or in a different session.
Okay.
Makes sense.
Yeah, let's do that. But yeah, it would be super interesting to go over that, and we can also try to analyze some particular example that we may need in the future, just to make sure we have like more experience about this and what would be useful.
Yeah, Good idea. Thanks.
No problem. Thank you guys. Hope it was useful, and feel free to come up with any questions or things to share.
Yep. Thanks, Vaku.
Okay.
Thanks, Paco.
Bye-bye.
Bye.
Bye bye.